Welcome to Math 104, Chapter 3 Intro, where we are now starting our quadratics journey. So first thing, we are now dealing with a degree of a polynomial that no longer is 1. So let's take a look at what our degrees do. So to tell the degree of a polynomial, we look for the highest exponent. So in the first view, can you determine what the exponent is, or what the highest exponent is? So in this one, we have the degree, which is 4. So 4 being the highest, we have 2. And technically, what do we have over here? Well, if we don't have an exponent exposed, it is technically a 1. Let's try it again here. Now, if we have two different types of variables to determine the highest one, we can always, again, expose the variable's exponent. And this one is pretty easy to tell because 2 is higher than 1. If we said we do not see the exponent, it's likely 1. And this one. Now, unlike the last one that we saw where we had two different variables and they were not attached, we could kind of make a comparison. However, if we have an exponent or variables where they are now being multiplied together, we can actually add the variable exponents together. So ours having a degree of now 6. 1 plus 5 is 6. And the last one is 1. So that is how you can determine your degrees of various forms. Now, often after finding your degree, we want to locate something called your leading coefficient, which is the coefficient of the highest degree. So see if you can determine what the leading coefficient is on these values. Well, because it is attached to your highest degree, our degree being 4, the coefficient of this term is 15. The leading coefficient here is negative 81. And on this one, again, if we're not seeing a coefficient, it is assumed to be 1. And the next few are pretty easy to see. We have 8. We have negative 4. Now the leading term, or the term leading coefficient is a little misleading because it sounds as if we are looking for the coefficient that comes first. But typically, while it does come first, it's only because it's due to our descending order or descending in degree, and then also by alphabetical. So can you try and write the following into a descended order? Descended order, your standard order, we want to look at your coefficients. We have we have 6. We do not have 1, so we have 0 here. We have 8, and we have 1. Now the coefficient of the degree of 4 is technically 1, but because it does not have a variable, your variable has a degree of 0 in this case. And if you wanted to put that in, you could say x is equal to 0. So, or a in this case, a. So if we are trying to work in descended order, we're going from highest to lowest. So 8, then we have 6, and then we have your 1, and then your constant at the end. So leading coefficient is now what? Your leading coefficient is 1/2. A lot of us, if we were to do it up here, would have maybe have said -5. It happens every time. So instead, always descended order so that you can see where the highest degree is, which is out front. Now we always want to order our terms from highest to lowest. We also had talked about terms. This was coming from our first, one of our first lectures. We said a term are values which are being added or subtracted. So if we're looking at the above, how many terms can we see? We have 1, 2, 3, 4 terms. There are 4 terms above. Now, the reason why this is important is we're now going to be starting our journey with not just quadratics, but with cubics and quartics. And it's just, we have a lot of terms to look at. So now let's look at a couple of quick rules of exponents. So can you figure out what is happening here? So this says if you have a variable, the exact same variable, and they both contain an exponent and they're both being multiplied together, we are going to add their exponents. So when variable are multiplied, we add the exponents. So let's try it out. Our x is our variable. They're being multiplied, so we are going to add 2 plus 5 to make 7. Now let's do it again here. Now we do see that the x cubed is on the outside of your parentheses, so let's go ahead and distribute it in. And we should get x cubed times x squared plus x cubed, which means your first term can combine 3 plus 2 makes x to the 5th. Now we are not able to add these two variables together to make x to the 8th because they are on like terms. We are only able to combine through multiplication or division. So after those examples, we are going to be working on multiplying exponents. So when multiplying exponents or polynomials, think of FOILing, which stands for first, outer, inner, and last. So if we were to see something like this example, if we were doing the FOIL method, well, we are just multiplying this A by this 2A. So multiplying your first two terms together, we get A times 2A, which makes 2A squared. Then we can move on. We go to A and negative 3B. I think I can draw that a little bit better. So this would be your two outer terms. That's where the word FOIL is coming from. We're just spelling it out. So then we can combine A and B just to be next to each other. And I'm actually going to scooch this down a little bit so I can make my little rainbows. All right, your next term, that was all of A. Now let's try your second term. Your two inner terms get multiplied together. 4B times 2A, which can combine into 8AB. B times A is the same thing as A times B. And last, we have your two last terms. 4B times a negative 3B, negative 12B squared. So now that you have it all listed out, can we combine like terms? Now, typically, we are able to combine your two middle terms So we have 2a squared plus 5ab minus 12b squared. So this would be your final result. Now let's try it again with some of these problems. Now, if all you need is to understand what the square is, no, we do not distribute in this squared term like this. It is not a monomial. So if we didn't have this minus sign and we just had 3x all squared, then by all means we can distribute it in. However, because you have a subtraction or an addition sign, we are now going to have to write out two of them. It just says we have two of these x minus 3's. Now, if that is all you need, please pause the video and try out FOIL method. So your first two terms can come together as x times x squared. So that is this one right here. Then we're going to move on to your two outer. We have plus x times -3 times these two terms, the two middle ones, -3 times x, and the remaining. And combining your like terms. And there you go. Let's try it one more time now with foiling, with not just a binomial, which means we have two terms. We are now going to expand it out to 3 terms, a trinomial, 1, 2, 3. So the only difference is that you're just going to be doing an additional multiplication. So we are multiplying these first two terms here, which makes x cubed plus, and then our next term and another one. And then again, one more time, but just on the 4s. All right, so let's do it again with -4. And last one. So at this point, we can try to combine your like terms if we have any, which we should have some. Notice that right here, we have a squared and a squared. We have an x and an x that can combine, and that looks to be it. We also want to make sure that we are writing in descended order. So largest value first, and then slowly trickling down. And there we have our final result. Now, the opposite of what we were just doing is called factoring. So this is called foiling as to what we were just doing. Multiplying polynomials is foiling. It just means that this is its most simplified form to start, and then look at how complicated that it can look like. Simplified, nice and looking, and all expanded. So the reverse of that is called factoring. Now, one thing we can work on factoring to start is called your greatest common factor. I like to use what's called the highlighter method. If it is too elementary for you, please feel free to skip if you already know how to do GCF. This is for students who really have a hard time factoring out just common terms. So with your highlighter method, your greatest common factor just means, hey, of these two terms, one term, two terms, what do they have in common? So these ones, if we're looking at your coefficients to start, what do 4 and 18 have in common for coefficients? Well, 4 and 18 both share 2. So let's rewrite your 4 and 18 to really expose and show your 2. We also have a negative sign that I'm going to include here. Whatever the sign is, I just like to show it. So if that is your coefficient, let's then look to your next variable. Now, how many x's do we have in x squared? Well, we have 2 x's, so I'm going to write out 2 of them. Whereas the one next to 18 only has 1 x. Let's do it again for your y's. 1, 2, 3 y's, and on the other side, 1, 2, 3, 4. Now for your GCF, for this highlighter method, we're just going to highlight what they have in common. So in your coefficient, they both share a 2 in common. So I'm going to highlight that. They can only have 1 x in common. You cannot take off, you can't take more than you're allowed. And if we keep moving, we have 3 y's and 3 y's over here. So anything that you get to highlight is found on the outside. 2 x y. Or sorry, 2 x and 3 y's. You took out all 3, so we're going to show that our y's we took out was 3. We only took out 1 x and just a 2. Now, anything that we did not highlight will remain in parentheses. So notice left over, we have a 2x, a minus sign, a 9, and a y. And that is factoring with GCF. So I recommend pausing the video and trying out the next examples. Okay, so 5 and 10 both have a 5 in common. So I'm going to break both of these up by 5s. This also has a minus or a negative sign. We have 2 x's here and 1 here. So when I go to highlight, I'm going to highlight my 5. I'm going to highlight 1 x. So we take out a 5 and an x. Those are the ones that are highlighted. And what is not highlighted is what's left over. Now, you do not need to include this one if you don't want to. It is totally up to you. Okay, something a little lengthier. We have 9 and 3, negative 3 times 3, negative 1 times 3. You got 4 x's. You have 7 y's, but looking over here, we don't have any y's. So I'm just going to write y to the 7th. We do have 2 z's, 3 over here. And again, no w's to start on that first term, but 5 over here. Okay, so time to highlight. We have not only a 3 in common, but we also have a negative in common. Now what that's going to do is that is going to change your signs on the inside. We now also have 1, 2, 3, 4, 1, 2, 3, 4 x's. We don't have any y's. We do have 2 z's in common. So we're going to take out a negative 3, 4 x's, and 2 z's. Left over, we have 3, 7 y's, a 1, a z, and 5 w's. Now your sign change, again, if we don't want that 1, we don't have to. Your sign change goes from a negative that used to be there and now is a positive. Everything on the outside, we can always double check that we took out the correct amount. And there you go, factor by GCF. Now, what is a polynomial? Our algebraic expressions that do not have negative exponents or variables in the denominator. Okay, so no negative exponents or variables in the denominator. Think about what it meant to be linear, right? We said, well, linear is just, you can have two variables still, that is okay within your expression, right? Y equals 2x plus y, right? But we also said for linear, it cannot have a degree that's more than 1, and it cannot be any variables in the denominator. Now, those lines aren't exactly considered a polynomial. They do not have negative exponents and they do not have variables in the denominator. With a quadratic, now we're stepping up your exponents to now have an exponent of 2. If we were talking about cubics, they would have exponents of 3, but still they are not able to have negative exponents or variables in the denominators. So some of the below are examples of what it means to not be a polynomial. Everything that we have been exposed to so far is a polynomial, whether that is one term called a monomial, one term, something like 7x, 14xy, or perhaps it's x squared, a binomial, which has two terms, 7x plus 4, 2x squared plus x, or a trinomial. Three terms, x squared plus 3x plus 2, 4xy plus 6 minus 1. Right, all examples of variables that do not have negative exponents or variables in the denominator. I could have sworn there was another page here. And I believe that is it as far as polynomials and the difference between those. So notice that here you have a variable in the denominator, looked super promising. We have a square root, which will have a fractional exponent. So again, another one that does not pass, and one that is now comprised of division. So these ones are not the ones that we're going to be working with.